Hello and welcome. I am Christopher John Björknes. It is August 24th, 2022. Many people mistakenly believe that Albert Einstein was the first scientist to derive the formula E equals mc squared. They also mistakenly think that he created the idea of the mass-energy equivalence. And the subject of today's talk, they believe that he was the father of the atomic bomb. None of those things are true, actually. As I'll prove, Albert Einstein did not believe that atomic bombs were possible. He didn't really understand the mass-energy equivalence or the formula E equals mc squared, which he derived from Henri Poincaré. The facts point in quite a different direction. There was a man named Samuel Tolver Preston who first described atomic explosions. He derived the formula E equals mc squared and said that matter was equivalent to energy and could be converted into energy because it represented a tremendous store of energy. Gustave Le Bon said very similar things. And I'm going to show you samples of their writings which prove this. First, let's take a look at what it is that Einstein thought could not be achieved.
On July 19th, the D-Day of Operation Crossroads, the atomic bomb supervised by Vice Admiral Blandy at Bikini Atoll in mid-Pacific. The B-29 Dave's Dream takes off from Kwajalein to deliver the bomb, equal to 50,000 tons of TNT, while an electric metronome counts the final seconds. Cover your eyes.
Don't cover your eyes.
Now, on the way. Radioactive cloud rises over 7 miles. 1, fire. Plutonium, half the weight of a dime, caused this.
It's important to take note of what he just said. Half a dime's worth of plutonium by weight can represent an extreme amount of explosive force. That's something that Albert Einstein didn't understand until the bombs were actually developed. But Samuel Tolver Preston and Gustave Le Bon discussed it. Preston in 1875 and Le Bon in 1903 and 1905. So pay attention to that quote because it comes up in their writings.
This is the force that can destroy our world unless we find the road to peace now.
5, 4, 3, 2, 1. See it again in stop motion. The light flash, the heat wave, and clouds of dust.
I hope we never get to see this live. So Albert Einstein didn't believe that atomic bombs were possible. He played no role in the development of atomic bombs. Oppenheimer didn't want him involved in the Manhattan Project. The only thing that Einstein had to do with the development of the atomic bomb was he signed a letter that had been written by Szilard, Edvard Teller, and Eugene Wigner that was addressed to President Roosevelt, encouraging Roosevelt to initiate what was to become the Manhattan Project. And I doubt Einstein believed it would ever be successful. Szilard had to sit down with Einstein and explain to him the research that he had been doing and the research that Enrico Fermi had been doing that proved that atomic bombs were not only theoretically possible, but actually could be developed in a fairly short time. Einstein didn't think atoms could be shattered, but Preston did, and Le Bon did. Frederick Soddy did in 1908, and there was a whole book written about the coming atomic wars by H.G. Wells in 1914, and Einstein was way behind the curve on all of this. And let's read some of what Einstein had to say about atomic energy and atomic bombs. This was as late as December 29th, 1934, and it proves that he didn't really understand the mass energy equivalence or the formula E equals mc squared. And he poo-pooed the idea that human beings would ever be able to derive atomic energy or build atomic bombs. He gave a talk, and it was reported on in the Pittsburgh Post-Gazette, which states, "Atom energy hope is spiked by Einstein. Efforts at loosing vast force is called fruitless. Savant talks here. Now indicates doubt of relativity theory he made famous." That is the contention of Professor Albert Einstein, but the energy of the atom is something else again. If you believe that man will someday be able to harness this boundless energy to drive a great steamship across the ocean on a pint of water, for instance, then, according to Einstein, you are wrong now. Energy of atom. The idea that man might someday utilize the atom's energy brought the only emphatic denial from the noted scientist yesterday. That would be Einstein. But on the near impossibility of atomic power, he was explicit. Like shooting in the dark. It's like shooting birds in the dark in a country where there are only a few birds, he said, illustrating his belief that molecule transfers, which would be necessary to the atomic power system, are too improbable for practical mechanical use. We have no means to force the transfers which do not consume more energy than the transfers give out, he said. From that point on, Dr. Einstein was plunged into the complexities of physical theory. In former days, the belief was that you can verify the principle of causality, cause and effect, he began. So as late as 1934, Einstein was still denying the possibility of atomic energy and atomic bombs. But this was a long-term belief he had held. In 1932, he said, "There is not the slightest indication that nuclear energy will ever be obtainable. It would mean that the atom would have to be shattered at will." Now, he wasn't the man who created the idea that atomic shattering atoms would release energy. That was developed long before him by much better minds. Einstein's friend, Alexander Moskovsky, wrote a biography about Einstein called Einstein the Searcher. Einstein bragged quite a bit in this book, and Max Born and his wife Hedwig Born wanted to sue Moskovsky to prevent the publication of this book, which revealed a lot of the truth that Einstein's critics had been saying, that he was a self-promoter, that he was the Barnum of science, essentially that he was a circus clown promoting himself to the world. Born was unsuccessful, but they did manage to get a lot of the book censored out and pared down so that Einstein wasn't presented as such a self-aggrandizing jackass. At any rate, Moskovsky wrote, "If, however, we should be compelled to depend on coal, our imaginations cling so much more closely to that enormous quantity given by the expression mc squared. M is mass, c represents celeritas, the speed of a wave in its medium, in this case the velocity of light, which was derived from the theory of relativity. The 20 billion calories that are contained in each gram of coal exercise a fascination on our minds. And although Einstein states that there is not the slightest indication that we shall get at this supply, we get carried along by an irresistible impulse to picture what it would mean if we should actually succeed in tapping it." Moskovsky was another one of the better minds who understood that atomic energy and atomic bombs were coming and that Einstein was wrong. Moskovsky knew this was true because he had read the works of people like H.G. Wells, Frederick Soddy, and Gustave Le Bon, among many others. How alluring is the song of sirens chanted by our physics with its high C, the velocity of light to the second power, which we have got to know as a factor in this secret store of energy. But these dreams are futile, for Einstein, to whom we owe this formula so promising of wonders, not only denies that it can be applied practically, but also brings forward another argument that casts us down to earth again. And then Einstein goes on to quote statements made by others as if he had thought of them, describing what a calamity nuclear war would be. This was clearly expressed by H.G. Wells and countless others before Einstein, as Moskovsky points out in his book. One of the first to describe a force existing within the ether that contains tremendous power beyond anything we have experienced in our lives was Edward Bulwer Leighton, who wrote a science fiction novel in 1835 in which he described this force as the force of vril. It was Leighton who came up with the idea of mutually assured destruction, resulting in a peaceful world, which was the mythology that was put forward and the reason that traders in America gave for transferring the atomic bomb secrets from the United States to the Soviet Union to create a bipolar world in which there would be mutually assured destruction. Edward Bulwer Lytton wrote in 1835, "But the effects of the alleged discovery of the means to direct the more terrible force of vril were chiefly remarkable in their influence upon social polity. As these effects became familiarly known and skillfully administered, war between the vril discoverers ceased, for they brought the art of destruction to such perfection as to annul all superiority in numbers, discipline, or military skill. The fire lodged in the hollow of a rod, directed by the hand of a child, could shatter the strongest fortress, or cleave its burning way from the van to the rear of an embattled host. If army met army, and both had command of this agency, it could be but to the annihilation of each. The age of war was therefore gone, but with the cessation of war, other effects bearing upon the social state soon became apparent. Man was so completely at the mercy of man, each whom he encountered being able, if so willing, to slay him on the instant, that all notions of government by force gradually vanished from political systems and forms of law. It is only by force that vast communities, dispersed through great distances of space, can be kept together. But now there was no longer either the necessity of self-preservation or the pride of aggrandizement to make one state desire to preponderate in population over another. Again, this was the principle of mutual assured destruction, iterated in 1835 by Edward Bulwer Leighton, based upon the concept of a new force he called vril, which would exceed any other force and would be genocidally destructive if employed against human beings. The great Samuel Tolver Preston formulated the mass energy equivalence in 1883. He wrote in an article published in the prestigious journal Nature entitled The Ether and Its Functions, "Let us not deviate from the well-tried ground of the atomic constitution of matter, already won with so much labor, unless we are forced to do so, and let us work towards the great generalization of the unity of matter and energy." It was really S. Tolver Preston who first conceived of the idea of an atomic explosion, and he derived that from his formula E equals mc squared, where E is energy, m is mass, and c is the velocity of light. I have an entire book on Samuel Tolver Preston available at my website, CJBBooks.com. It's a complete works of all his works on atomic energy and on the formula E equals mc squared and atomic bombs. I highly recommend it. It is a massive tome of Preston's collected works. Preston wrote in 1875 in his book, Physics of the Ether, "If now we imagine, merely for illustration, each of these air molecules to be subdivided into 1,000,000 parts, and that the speed of each component part has been increased 1,000 times, the presence of the ether within the receiver may be left out of account for the present. Then, by this imaginary process of subdivision, the mean distance of these parts of matter, which we shall term particles," he's now describing subatomic particles in 1875, "would be so reduced as to bring these particles into closer proximity than the molecules of air outside the receiver, the mean distance of the particles of the subdivided matter being inversely as the cube root of their number. The pressure against the interior of the receiver, which is as the square of the speed of the particles, would now be increased 1,000,000-fold, and yet this result is attained without any increase in the absolute value of the energy of each particle. For the energy has, by the reduction of mass, remained precisely the same for each particle as before, although the total energy has become vastly greater, this energy being now subdivided among the large number of particles and the pressure maintained by a greatly increased number of moving particles." This is the working operational principle of an atomic bomb, in which the subatomic neutrons are released from matter which has obtained critical mass within a container that amplifies the chain reaction that produces the nuclear explosion. Preston designed all of this in 1875, 4 years before Albert Einstein was even born. We might imagine this process of subdivision, or this reduction of mass combined with increase of speed, to go on progressively, and thus the total energy would be continually increasing, and the mean distance and mean length of path of these small moving masses or particles would be continually diminishing, and therefore the concealment of this motion from the senses would be more and more complete. The pressure would continually rise in intensity, and at the same time become more even and perfectly balanced as the number of particles increased. We might thus imagine this process to go on progressively until at length the dimensions, mean distance, and speed of the ether particles themselves had been reached. That's the velocity of light. Or it is possible thus, step by step, to arrive at a just conception of the wonderful intensity of the store of energy that is rendered physically practicable, and the high static value of the pressure that may be reached under the simple mechanical conditions of an extensive subdivision of matter combined with a high speed. He's describing a nuclear chain reaction producing a nuclear explosion. Preston, later in this book, among the many other tremendous innovations such as superconductivity and many other things I don't have time to go into now, stated in section 165. To give an idea first of the enormous intensity of the store of energy attainable by means of that extensive state of subdivision of matter, which renders a high normal speed practicable, it may be computed that a quantity of matter representing a total mass of only 1 grain and possessing the normal velocity of the ether particles, that of a wave of light, encloses a store of energy represented by upwards of 1,000 millions of foot-tons, or the mass of 1 single grain contains an energy not less than that possessed by a mass of 40,000 tons moving at the speed of a cannonball, 1,200 feet per second. Or otherwise, a quantity of matter representing a mass of 1 grain endued with the velocity of the ether particles, which is the velocity of light, encloses an amount of energy which, if entirely utilized, would be competent to project a weight of 100,000 tons to a height of nearly 2 miles, 1.9 miles. This remarkable result may serve to illustrate well the intense mechanical effect derivable from small quantities of matter possessing a high normal velocity, the extremely high value of the effect depending on the fact that energy rises in the rapid ratio of the square of the speed. Now remember that phrase, plutonium half the weight of a dime caused this. Preston had been describing this 70 years before the atomic bombs were dropped on Nagasaki and Hiroshima. Another brilliant mind who understood all of this long before the experiments of Fermi and Szilard was Gustave Le Bon. Le Bon had written to Einstein demanding that he acknowledge his priority, Le Bon's priority, for formulating the mass-energy equivalence before Einstein, and for stating that matter is itself a form of energy, which he called intra-atomic energy. Le Bon did extensive research on radiation in the 1890s and early 1900s, and his ideas were the product of experimental discoveries, not the product of plagiarism, as was Einstein's plagiarism of Poincaré's formula E equals mc squared. Le Bon summarized his work in his book, The Evolution of Matter, which was published in French in 1905 and then translated into English in 1907. And the ideas I'm going to state here were essentially fully developed in an article he published in 1903, Intra-Atomic Energy, in the Scientific Review in France, in French. In October of 1903, it was published. The full citations are on the slide. In 1905, he reiterated these ideas, which again he had fully developed back in 1903. Matter hitherto deemed indestructible vanishes slowly by the continuous dissociation of its component atoms, hence the evolution of matter. The products of the dematerialization of matter constitute substances placed by their properties between ponderable bodies and the imponderable ether, that is to say, between two worlds hitherto considered as widely separate. Matter, formerly regarded as inert and only able to give back the energy originally supplied to it, is, on the other hand, a colossal reservoir of energy, intra-atomic energy, which it can expend without borrowing anything from without. So Le Bon fully understood in 1903 that matter is energy and that it contains a tremendous reservoir of energy, as Preston had said in 1875. It is from the intra-atomic energy manifested during the dissociation of matter, which Preston described as the subdivision of matter, that most of the forces in the universe are derived, and notably electricity and solar heat. Force and matter are two different forms of one and the same thing. Matter represents a stable form of intra-atomic energy. Heat, light, electricity, etc. represent unstable forms of it. The dissociation of atoms, that is to say, by the dematerialization of matter, the stable form of energy termed matter is simply changed into those unstable forms, known by the names of electricity, light, heat, etc. The law of evolution, applicable to living beings, is also applicable to simple bodies. Chemical species are no more invariable than our living species. Le Bon also wrote, "The practical interest of the doctrine of the vanishing of matter by reason of its transformation into energy. The vanishing of matter by reason of its transformation into energy will only appear when means are found of accomplishing with ease the rapid dissociation of substances." This is what Einstein got hung up on, but he was not the first one to raise the point. Le Bon was. When that occurs, an almost unlimited source of energy will be at man's disposal gratis, and the face of the world will be changed, as indeed it was. But we have not yet reached this point. It would be reached within 40 years. Certainly, it would be quite different if radium or any other substance were dissociated rapidly instead of requiring centuries for the purpose. The scholar who discovers the way to dissociate instantaneously 1 gram of any metal, radium, lead, or silver, will not witness the results of his experiment. The explosion produced would be so formidable that his laboratory and all the neighboring houses with their inhabitants would be instantly pulverized. So Le Bon fully understood the implications of the mass-energy equivalence in 1903, and he described a nuclear explosion in 1905. And again, think of that phrase, plutonium half the weight of a dime caused this. Le Bon described that in 1905, long before Einstein had any understanding of any of this. And Einstein did not believe that atomic bombs would be practical and possible until they actually started going off. Frederick Soddy, who was cited by H.G. Wells as the source and inspiration of his novel on atomic bombs, which would be published in 1914, wrote in 1908, or gave a lecture in 1908, stating, "I have already referred to the total amount of energy evolved by radium during the course of its complete change. It is about 2 million times as much energy as is evolved from the same weight of coal in burning. The energy evolved from uranium would be some 14% greater than from the same weight of radium. This bottle contains about 1 pound of uranium oxide, and therefore about 14 ounces of uranium. Its value is about 1 pound. Is it not wonderful to reflect that in this little bottle there lies asleep and waiting to be evolved the energy of about 900 tons of coal? The energy in a ton of uranium would be sufficient to light London for a year. The store of energy in uranium would be worth 1,000 times as much as the uranium itself, if only it were under our control and could be harnessed to do the world's work in the same way as the stored energy in coal has been harnessed and controlled. As we have seen, we cannot yet artificially accelerate or influence the rate of disintegration of an element, and therefore the energy in uranium, which requires 1,000 million years to be evolved, is practically valueless. On the other hand, to increase the natural rate and to break down uranium or any other element artificially is simply transmutation. If we could accomplish the one, so we could the other. These two great problems, at once the oldest and the newest in science, are one. Transmutation of the elements carries with it the power to unlock the internal energy of matter, and the unlocking of the internal stores of energy in matter would, strangely enough, be infinitely the most important and valuable consequence of transmutation. Again, this was Soddy speaking in 1908, before Einstein had any conception of any of this. Soddy was highly regarded and widely read. Obviously, we were only at the beginning of our knowledge of the internal stores of energy and matter, and the mere fact that these stores existed, and in a few actual cases within our knowledge, were slowly evolved and became available for the purposes of cosmical evolution, justified us in regarding them as probable, as they were certainly the sufficient first source from which the available energy of all nature was derived. Now the trick was to accelerate that disintegration of matter that Preston had described in 1875, so that tremendous store of energy was released all at once instead of being released over the course of thousands of millions of years, billions of years. It cannot be denied that, so far as the future is concerned, an entirely new prospect has been opened up. By these achievements of experimental science, man's inheritance has been increased, his aspirations had been uplifted, and his destiny had been ennobled to an extent beyond our present power to foretell. The real wealth of the world was its energy, and by these discoveries it, for the first time, transpired that the hard struggle for existence on the bare leavings of natural energy in which the race had evolved, was no longer the only possible or enduring lot of man. It was a legitimate aspiration to believe that one day he would attain the power to regulate for his own purposes the primary fountains of energy which nature now so jealously conserves for the future. The fulfillment of this aspiration is, no doubt, far off, but the possibility altered somewhat the relation of man to his environment and added a dignity of its own to the actualities of existence. Now, in this talk, I'm only going to cover those great minds who forecast and described atomic explosions long before the scientists actually began to work on the practical development of atomic bombs, long before Otto Hahn, Lise Meitner, Niels Bohr, Eugen Wigner, Edvard Teller, and Leo Szilard, Oppenheimer, and many others were involved in developing atomic bombs. That would be the subject for another day. Today I'm only describing those who are the actual fathers of the concept of the mass energy equivalence, of the formula E equals mc squared, and of the design of and possibility of atomic bombs, which were described by H.G. Wells in his novel, The World Set Free, A Story of Mankind, published in 1914. I'm only going to read a few brief excerpts from this book to demonstrate the fact that he literally described atomic bombs and the materials that would eventually be used to make them, and that all of this was understood by H.G. Wells in 1914. He knew it was coming before Einstein had even conceived of any of this as a possibility and had rejected that possibility. And we now know that the atom, that once we thought hard and impenetrable and indivisible and final and lifeless, is really a reservoir of immense energy, and that had been stated by Preston, Le Bon, and Sadi. That is the most wonderful thing about all this work. A little while ago, we thought of the atoms as we thought of bricks, as solid building material, as substantial matter, as unit masses of lifeless stuff, and behold, these bricks are boxes, treasure boxes, boxes full of the intensest force. This little bottle contains about a pint of uranium oxide, that is to say, about 14 ounces of the element uranium. Again, Wells is basing this on the work of Sadi. It is worth about £1, and in this bottle, ladies and gentlemen, in the atoms in this bottle, there slumbers at least as much energy as we could get by burning 160 tons of coal. If at a word in one instant I could suddenly release that energy, here and now, it would blow us and everything about us to fragments. If I could turn it into the machinery that lights this city, it could keep Edinburgh brightly lit for a week. But at present, no man knows, no man has an inkling of how this little lump of stuff can be made to hasten the release of its store. It does release it. As a burn trickles, slowly the uranium changes into radium. The radium changes into a gas called the radium emanation, and that again to what we call radium A. And so the process goes on, giving out energy at every stage, until at last we reach the last stage of all, which is, so far as we can tell at present, lead. But we cannot hasten it. That is what was accomplished by Otto Hahn that inspired Lise Meitner, to inform Niels Bohr that atomic bombs were actually practicable and possible. His companion, a less imaginative type, sat with his legs spread wide over the long coffin-shaped box, which contained in its compartments the 3 atomic bombs. The new bombs that would continue to explode indefinitely, and which no one so far has ever seen in action. Note that Wells used the term atomic bombs expressly. Hitherto, carolinum, their essential substance, had been tested only in almost infinitesimal quantities within steel chambers embedded in lead. Beyond the thought of great destruction slumbering in the black spheres between his legs, and a keen resolve to follow out very exactly the instructions that had been given him, the man's mind was blank. His aquiline profile against the starlight expressed nothing but a profound gloom. So this was Wells expressly speaking of atomic bombs in 1914. Also in 1894, he wrote the book The Time Machine, in which he said that time is a 4th dimension. That was also an idea which Einstein rejected, though he is today given credit for it. He vehemently rejected it in a couple of articles he wrote with Jacob Laub in 1907, expressing his objections to Minkowski's interpretation of Poincaré's theory of relativity and the idea that time was a 4th dimension. Wells also wrote, "I do not think any of us felt we belonged to a defeated army, nor had we any strong sense of the war as the dominating fact about us. Our mental setting had far more of the effect of a huge natural catastrophe. The atomic bomb had dwarfed the international issues to complete insignificance. When our minds wandered from the preoccupations of our immediate needs, we speculated upon the possibility of stopping the use of these frightful explosives before the world was utterly destroyed. For to us it seemed quite plain that these bombs and the still greater power of the destruction of which they were the precursors might quite easily shatter every relationship and institution of mankind. Now, 108 years later, we are in danger of the fulfillment of what H.G. Wells forecast in 1914. We're at the precipice of the abyss, I'm afraid. After the bombs had been dropped on Hiroshima and Nagasaki, Albert Einstein, who was a globalist, took advantage of the opportunity to both deny any responsibility for developing the atomic bombs and also to call for fulfillment of his messianic prophetic goal of creating a world government and creating a nation in Palestine, a Zionist nation, and thereby fulfilling the 2 messianic goals of Judaism, of a world government run from Zion, as prophesied by Isaiah in chapter 2, and of the restoration of the Jewish people to Palestine to form the nation of Israel, which was his Zionist ambition from very early on through the end of World War II. He wrote, "I do not consider myself the father of the release of atomic energy. My part in it was quite indirect. I did not, in fact, foresee that it would be released in my time." Note that many others did foresee that it would be released, and Einstein isn't telling the full truth. He thought it was impossible, not merely that it wouldn't be released within his time. He thought it was impractical. It couldn't be done. I believed only that it was theoretically possible. That's a lie. He believed that it was not theoretically possible. It became practical through the accidental discovery of chain reaction. And this was not something I could have predicted. Well, many other people did predict it. It was discovered by Otto Hahn, in Berlin, and he himself misinterpreted what he discovered. It was Lise Meitner who provided the correct interpretation and escaped from Germany to place the information in the hands of Niels Bohr. I do not believe that the secret of the bomb should be given to the United Nations organization. I do not believe it should be given to the Soviet Union. Either course would be like a man with capital and wishing another man to work with him on some enterprise, starting out by simply giving that man half of his money. The other man might choose to start a rival enterprise, when what is wanted is his cooperation. The secret of the bomb should be committed to a world government, and the United States should immediately announce its readiness to give it to a world government. This government should be founded by the United States, the Soviet Union, and Great Britain, the only three powers with great military strength. All three of them should commit to this world government all of their military strength. The fact that there are only three nations with great military power should make it easier rather than harder to establish such a government. Such a government was forecast 2,500 years before this in the Old Testament. It should not be forgotten that the atomic bomb was made in this country as a preventative measure. It was to head off its use by the Germans if they discovered it. The bombing of civilian centers was initiated by the Germans and adopted by the Japanese. To it, the Allies responded in kind, as it turned out, with greater effectiveness, and they were morally justified in doing so. That was Einstein's opinion. He also said that the German people should be exterminated, and that was based on the principle of collective punishment, which Albert Einstein endorsed. Well, I hope you've learned quite a bit from this presentation. Please spread the word. Albert Einstein was not the father of E equals mc squared, the mass equivalence, atomic energy, or the atomic bomb. There were better, brighter, earlier minds who came up with all of these notions long before Albert Einstein. It's strange that he's given credit for all these things when he himself sought to distance himself from the atomic bomb, but utilized it as a pretext to initiate the world government he had been calling for well over probably 40 years before he made those statements. If you'd like to learn more about all of this, I've written several books on these subjects, which you can find at my website, CJBBooks.com. Two of the books which pertain most directly to this would be Einstein's plagiarism of E equals mc squared and the mass equivalence, and my book on Samuel Tolver Preston, which includes all of his writings in which he stated that matter is a store of a massive amount of energy, and that the formula used to calculate that store of energy is E equals mc squared. That was in 1875, 4 years before Einstein was born. If you got any benefit from this presentation, please consider donating. There will be a PayPal link in the description below. Better yet, go to CJBBooks.com and buy a dozen or so books and educate yourself about all these facts. I'm the only person in the world disseminating this information who has done all the research and proven all of these things. So please support my work. It will benefit you as well. Thank you very much. Bye-bye.